All right, well, good afternoon, good evening, or good morning, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate. Just use your question and answer tab on the interface and submit your question, and we'll get to as many as we can near the end of today's webinar. We also have an interactive chat feature on the interface, and I'll be chatting you guys up throughout the webinar. I hope you'll be chatty with me as well. We want to try and make this as interactive as possible. We also have a couple handouts for you in the handouts section of the interface, so please check those out. They are free for you to download at your leisure, or you can just take a look at them on the interface as well. And finally, at the end of today's webinar, we are going to be doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is Telegraf and InfluxDB at Mist.io, or how to gain visibility into containers, VMs, and multi-cloud environments using Telegraf, InfluxDB, and Mist. Our speaker today is Chris Psaltis, who is the CEO and co-founder of Mist.io. Hello, Chris. Thank you so much for joining us from Greece. Appreciate you being here.
Hello. Thank you for hosting me.
No trouble at all. I'm going to take myself off camera, put myself on mute, and let you get right to your presentation. I know it's a good one.
Thank you. Okay, so let's begin. I'm Chris, I'm the co-founder and CEO of Mist.io, and today I'm going to walk over how you can gain visibility into your containers and your VMs, especially when in multi-cloud environments, using Telegraf, InfluxDB, and our platform, Mist.io. First of all, I will begin with a little introduction into what is Mist. Then I will go over how we integrated with Telegraf and InfluxDB. I will do a live demo of the platform, and I will focus on the parts of the integration, specifically on monitoring with InfluxDB. And then I will finally go over some of our plans for the future. So first of all, what is Mist? Mist is an open source multi-cloud management platform. And by that, I mean that you can leverage our tool to manage your infrastructure across more than 20 supported infrastructure providers like AWS, Azure, but also private clouds like OpenStack, VMware stuff, containers, and even bare metal servers. So from one hand, Mist connects to all those different cloud providers over their native APIs. And then from the other hand, it exposes a single multi-cloud API. So you can think of Mist as a single pane of glass from where you can manage your infrastructure across all those providers. We started building Mist in order to scratch our own itch. And back then, we were running a consulting agency. Our customers had infrastructure all over the place. We were managing it for them. And we almost daily had questions like, what resources do we have? How can we control our team members' access to all those resources? Can we automate self-service workflows so we can make it easier for our end users to provision new servers as they go? And obviously, how can we optimize usage? Can we reduce cost and save our customers some money? And that's why we started building Mist, because we were trying to get answers to all those questions. And such answers are really critical for infrastructure management, which is all about making decisions. It's all about making decisions. And to make good decisions, you need data. And here's where monitoring metrics come in. And that's one of the key reasons why they're really important when managing infrastructure. So since the early days of our platform, we integrated with monitoring tools in order to collect, store, and show monitoring metrics to our users from within our platform. Now, over time, these tools have evolved. We started with CollectD and Graphite, but nowadays we are integrating with Telegraf and InfluxDB. And we did this transition over time mostly because of the level of flexibility that Telegraf and InfluxDB are bringing on the table. So from the Telegraf side of things, when you compare it to CollectD, Telegraf is written in Go. This means that you have a single binary which you need to install. Installation can be automated very easily, whereas with CollectD, which is written in C, we had to deal with links to system libraries, which made it practically impossible to install in all distributions, versions, and all of that. So with Telegraf nowadays, we can easily deploy it on pretty much any OS. Also, Telegraf is much better maintained. You can check this out in GitHub. It's almost 4 times better across all metrics like number of commits, contributors, etc. They do monthly or bi-monthly releases, whereas with CollectD, we had 6-month cycles, meaning that we get fixes much faster than we used to. And this extends to the plugins supported by Telegraf. Now, the situation is pretty much similar with InfluxDB. InfluxDB brought a whole new level of flexibility. For example, with Graphite, we had to pre-configure the granularity of the ingested metrics. We had to pre-allocate the disk space for storing those metrics. With InfluxDB, we don't have to worry about any of that. So we just plug it in and it's rolling. But besides the flexibility part, which I went into more detail, there are other reasons for choosing Telegraf and InfluxDB. A big part of our decision was influenced by the open source components. Both Telegraf and InfluxDB are real open source. I mean that in the sense of Apache v2 license, MIT license. You can hack them, you can redistribute them. Contrast that to code available options out there. It's a huge difference. And they also give us the opportunity to tap in a big and vibrant ecosystem. This means that we can use third-party integrations, we can move faster, we can quickly find solutions to our problems without having to reinvent the wheel. And then finally, our user base is probably already familiar with the Telegraf and InfluxDB. This means that we don't have to introduce unknowns to their environments. They might be having something already running. So it's much simpler for them to adopt our platform, and we reduce friction for them along the way. Now, here's an overview of how everything is working together. So this is like a high-level architectural diagram. At the top, we have Telegraf. Telegraf gets installed in VMs. It's collecting metrics and then sending them back to a Mist installation. These metrics go through a relay. We call it Goalkey. Goalkey does 2 things. First of all, it pushes all the monitoring data to InfluxDB, but it also keeps track of metering data, like how many metrics I have ingested and things like that. And then everything gets stored in InfluxDB. And from there, we have another component we call Cilia, which is constantly querying the monitoring data as well as log data, which we store in Elasticsearch, and triggers specific actions when user-defined conditions are met. So Cilia is the rule evaluation component of all this. In more details now for Telegraf, as I said, we automatically install it on Windows Server VMs using PowerShell. but we can also install them on Linux systems using bash scripts. By default, we don't deploy any Telegraf plugins other than the Python plugin, and we do that in order to allow our users to configure through the web custom metrics. Now, the relay I was talking about, which we call Goalkey, is based on a fork of the InfluxDB relay. We're using this so we can horizontally scale our ingestion layer, but we are also using Goalkey so we can count every ingested metric that comes our way. We have modified Goalkey so it can support both InfluxDB and Graphite, so we have a smooth transition from the old system to the new one. For InfluxDB now, we're running 1.8.4. By default, we zip the open source version of InfluxDB in a container, but you can bring your own. We also support InfluxDB Enterprise. So if you have an environment already in your running in your systems, you can just plug it in Mist. And as you probably seen already, InfluxDB is where all the time series data are stored. And then finally, the Cilia component, as I said, it constantly queries monitoring data in InfluxDB and logs that we are collecting in Elasticsearch. It evaluates the rules and it triggers actions like webhooks, sending email alerts, script execution, and several other. But let's see all of that in action. I have prepared a live demo for you. Let me switch to my demo account. So what I'm going to show you here is the enterprise edition of Mist, which is hosted on-prem. This is a totally empty account. The first thing you need to do is connect your infrastructure. Here you can see a list of all the supported providers. In all cases, you need to provide some sort of API credentials so you can connect to those clouds over their native APIs. Let's select DigitalOcean. I will paste my API token here, and that's it. Now, the moment Mist receives the API token, it starts polling your cloud accounts, and it auto-discovers the resources that you have running there. So, for example, you can see here, it already discovered that I'm running 4 VMs in my DigitalOcean account, and it can also give me a rough estimate of my burn rate. So just in just a couple of seconds, I know what I'm running, where, and a ballpark number of my cost. But let me switch to an account that's more populated so I can show you more things. I will go over all the basic functionality, let's say, of Mist, but I will also focus in the monitoring aspects of it. So in this account, I have connected 11 clouds, several AWS regions, DigitalOcean, Docker host, Google account, KVM host, an account in Linode, in Azure, in Equinix Metal, as well as a vSphere installation. So across all of those, I'm running currently 41 VMs. You can see the full list here. You can see the name of the VM, the state, the cost, some tags, metadata like sizes, IPs, who is the owner of the VM. So I don't have to go out on Slack and asking, oh, I have found this VM. It's called XAAD. Do you need it? What does it do? Whose VM is that? And all that. So let me show you one VM closer. So this is a VM I have running in Linode. I can perform all actions that you would probably expect, like starting, stopping, rebooting, destroying, things like that. I can also connect to it over SSH cell, so I can quickly troubleshoot. So at the top here, you can see all the basic information for this VM. This VM has monitoring enabled. These are real data coming from the VM system metrics through Telegraf and InfluxDB. Here you can see some rules that apply to this VM. And then finally, all the metadata coming from the provider. And at the bottom here, it's a full audit trail of what actions happened on this VM, by whom, what was the result, and things like that. So you can figure out what went wrong at some point if needed. But you cannot, it's not just these actions. You can provision new VMs. Let me show you what I mean. I will create a test VM in DigitalOcean. I will put it in Amsterdam. I will select a Debian image and the small size, let's say this one for $5 per month. And I will also give it an SSH key, which will be deployed to the VM, so I can later connect to it over SSH. Okay, so this started the provisioning process. Until this is done, let me show you a couple of more things. Like, you can quickly filter through all your resources through the search field here. So, for example, these are all the VMs I have running in Linode, and this is the full list of the VMs. All those filters can be saved and reused later. So, for example, here is a filter with my VMs running in AWS, so I can switch from just AWS to all or just my resources from here, and I can quickly find what I'm looking for. Oh, here it is, the test VM is up and running. You can see it here, it provisioned fine. But let me get back to that in a second. So similar to the listing of VMs, you also get volumes. These are block storage devices, EBS, for example, in AWS. You can quickly filter here, see what's attached, what's not attached. Networks, AWS VPCs, for example, zones. These are DNS as a service, Google DNS, Route 53, things like that. All my SSH keys. So from these sections that I've showed you, you can already understand that it's like really easy to get going. It's really simple to see what you have and start performing some actions. But what more can you do? What more can you do with the platform? Let me go into scripts for a moment. So from here, you can create a library of scripts and then execute them on your VMs. These scripts can either be executables, like bash scripts, for example, or they can be Ansible playbooks. Let me show you an example. So in this is just like a very simple example. It just prints hello world. I could select this one, pick a VM where I want this to run. If I need to provide some parameters, I put them there. I hit run, and this is it. With scripts, it's fairly simple to install an application or take a backup or clean up some logs, things like that. And one script is executed on a single VM, but in some cases, you need to do more complicated things like create a database cluster, for example, where we're talking about several VMs running at the same time with some networking, connecting everything, maybe some storage as well. So for those situations, we have the template section. In this section, we're integrating with another open source technology called Cloudify, which is similar to Terraform. In fact, we are working on Terraforming integration as we speak. So what you can do here is that you can bring your own template, upload it to Mist, and then run it on any of the connected providers. In this example, I have a Kubernetes blueprint. So what this will do is that it will allow me to create a new cluster with one master, one worker machine, again, on any of the connected providers that I have in my account here. Now, these were the template section, but let's also go a little bit further. Let's also review the schedules part. So here you can configure periodic tasks like taking backups, rotating your logs, tasks that will be executed on a specific schedule every day, every week, things like that. We also see schedules being used for proactively controlling your cost. So, for example, you have people coming to work in the morning, leaving in the afternoon, but they forget on-demand instances running. So what you can do with schedules is that you can, for example, stop all your machines with the tag dev, which are older than 1 day and cost more than $100 per month, and you can repeat this operation every day. So this way, what this is going to do now is that it will stop all your VMs. In most cloud providers, this means that you're not losing actual data, but you're also not getting charged. So even if somebody forgets a VM running, then this will automatically handle it. And next day, when they come to work, the VM will still be there and they can spin it up again. And, you know, I've showed a lot of things that our users can do, but I would also like to drill a little bit deeper here in the team section, where all the control aspects of Mist are. You can think of this section as cross-cloud IAM service. For anyone who has worked with even with one IAM service in the context of a single provider, you can already imagine how terrible it can be to try to extend this mechanism across multiple providers. So we try to make this really simple from here. We allow our users to create teams. They can invite new people to their teams over email, and new users will receive an activation link. They click on the link, they get in their respective team, and when somebody leaves the team, you can just delete their account from here. And then for its team, you can offer very, very fine-grained controls over all the resources and actions that are managed through Mist. So for example, let's say that our QA team, I want them to have full access only to my Ohio AWS account, and I would also like to give them full access to all the VMs with the tag QA. So it's that simple, and this will automatically apply to every item you have in your inventory. The role-based access controls support all resources that can manage through Mist and all the relevant actions. Now, from here, you can also do some additional stuff we call constraints, like, for example, apply cost quotas. I would like my QA team to have $1,000 per month quota. If they try to provision more than that, deny it. Or you can control who has access to which specific sizes. And this, again, makes it simpler to handle your inventory and share your infrastructure with your entire team. And that's with control aspects, but let's get back to the monitoring part for a second. So I would like to show you how the whole workflow of monitoring works. I have here the VM that I created earlier, this test VM. Okay, let's get there. Okay, so here you see this VM is not monitored by default. I will click enable monitoring now. And what this does right now is that it deploys Telegraf to this VM over SSH. Once Telegraf gets installed, then it will start collecting monitoring metrics and sending them back to Mist. As I showed you in the architectural diagram earlier, these will go through our relay, Goalkey, and they will end up being stored in InfluxDB. Yep. You see, this is running already, and it's sending the first metrics. Again, all the default system metrics here, but you can add more depending on what you would like to view. So out of the box, you get a wide range of supported system metrics, And as I mentioned earlier, you can also deploy your own custom metrics through the Python plugin. Let's call this my random metric. This is just an example. It generates a random value, but you can edit this Python script and do whatever you like fetching a value from an external system or pinging something. I will click on Add Custom Graph. And what this does right now is that it creates this Python script and it will deploy it to my VM. Okay, so you see here, it's already deployed and it's sending the first metrics back. All right, so on top of those metrics now, you can configure rules. So this is the rule section. Let me show you how this works. Let's say that I would like this rule to apply on all my machines. And if I see that, let's say my load average goes over a certain value for X number of times, then I would like Mist to alert me. This will be an email alert to a specific team or specific team members, or I would like to trigger a webhook, like a notification in Slack, for example. I could reboot the machine. I could destroy it if it's sitting idle, or I can run a script like I'm detecting that my web server is leaking memory. Let's run a script to automatically restart the web server. Now, those types of rules can apply both on monitoring metrics, but we are also supporting rules on logs. You can see an example here, and this rule will notify my team whenever a new VM gets created. The nice thing about the rules here is that they can automatically apply to new and old resources alike. So, for example, this rule will apply to all the resources with the dev tag, all the machines with the dev tag. Whenever I create a new VM, I put the dev tag on it, and that's it. I don't have to remember anything else. The rules policy will be automatically applied to this VM, and it will automatically apply to all existing resources that have this tag. And where everything kind of comes together is in our insight section, where we try to help our users answer some questions like what it is that I'm running, how much am I paying for it, and is this cost justified or not? Do I have VM sitting idle? Do I need to do something, or are they overloaded? What's the deal? So here we're bringing information across the board to help you with that. For example, here you can see what's your cost like and how it evolved over time, how it was distributed across clouds and across tags. Similar situation with the utilization and the metrics that we're collecting from monitored VMs. For example, here you see that I'm currently monitoring 3 cores in total, but my load is a little bit below 0.2. So probably I'm wasting capacity here and I need to do something about it. I will probably need to scale down some instances. Otherwise, I'm just spending money in vain. And then finally, the inventory and how it evolved over time. On Monday, I was running 28 VMs. Today, right now, I'm running 46 VMs. So here we combine information from all sorts of sources in order to help you very quickly decide if there is something you need to do about your inventory, if there are any scaling decisions that you need to take, and where are all those supposed to happen. Now, everything I showed you so far is powered by a RESTful API, and the web browser the web application is just another client of this API. What we are currently working on, this is still in preview, but we're very excited about it, is that we're leveraging the same API that I showed you so far in order to power CLI. So Mist CLI is a new way of interacting with the platform, and it will support at some point the full feature set that I showed you already. Right now it's a little bit early, but I can demo it right now to show you what I mean. The Mist CLI has a kubectl feeling to it for those who are familiar with kubectl. So you can do, for example, get cloud, and this will return the clouds that I have connected to the account. This is coming from the same account that I showed you already, but you can also do something like get machine, and here is the full list of the machines that I'm running. You can see here the test VM I created earlier. But let's say that you don't want the full list of machines, you just want to see your VMs running in Linode. So you could do something like, for example, search only for Linode instances. Here they are. And let's say now that you would like to export this information in another format. So Mist CLI allows you to export to a couple of formats, including JSON, YAML, CSV. So let's see the JSON output. So these are all the data for my VMs running in Linode, and also some meta information like how many results are in the reply. You can do a similar thing with YAML. So again, the same result, only in YAML format. And this is very useful if you would like to just get those values out from here and put them to another system. Overall, the CLI is really helpful for integrating in your existing workflows without having to go through the web. But you can also do other things, like, for example, let's say that I'm not interested to the full list of metadata for its VM. I'm just interested in the name and the cost, and I would like to export this to CSV so I can create a report about my spending. So here it is, again, the full list of the VMs with the name, the hourly cost, and the monthly cost. And finally, one last thing I wanted to show is that Mist. I wanted to show you how cell works from the command line. Let's say, let me connect to an InfluxDB VM. So this is a fully featured cell. Now it will, yep, here it is. So now I'm connected. I can start troubleshooting stuff. Here it is. So this is at the HTOP. And this works really nicely without having access to private keys from your local system. It's super easy to get started and share access to your VMs through that without having to worry about, oh, where is that key, who has access to it. And when new people get in your team, it's easier to add them. When they leave your team, it's also easy to remove them. And that pretty much concludes my my demo for today. I hope you found it useful. So let's go ahead with the presentation. I have a couple of more slides to wrap up. So a quick recap. I went over what is Mist, the open source cloud management platform, why monitoring metrics are critical, and how we've built on top of Telegraf and InfluxDB in order to provide those metrics to our end users. And finally, I went through the demo and the benefits that Mist users get. Now, in terms of next steps, as I said, we are currently running with InfluxDB version 1.8.4, but we plan to support version 2 as well. We are currently working a lot on our multi-cloud CLI, the one I demoed earlier. And for the future, we're very excited, and we're looking forward to InfluxDB IOX, which is the new engine for InfluxDB. It will bring a lot of new stuff, better performance, more cloud-native architecture, same open source license, which is a big plus for us. So stay tuned for that. And then finally, we're working on custom dashboards for our web interface. So all these information that we're collecting and putting in InfluxDB, as well as other sources, we want to enable our end users to quickly create custom dashboards based on that and quickly find the information they're looking for from a single place. So that's it for me. Thank you very much. I hope.
All right, great. Yeah, great presentation. And I'm a big fan of demos, so I just love watching those. So thank you very much for doing the demo as well. Hey guys, there's plenty of time for question and answer period. So if you do have a question for Chris, go ahead and use the question and answers tab and go ahead and get it on in. You can also add your question to the chat tab and we'll move it over for you, no big deal. But we have gotten some great ones in so far, so let me go ahead and just dive right on into the ones we have. Jayesh starts out by, how does monitoring using Mist differ from Prometheus and Grafana?
So it's kind of a different purpose, or just a new layer, let's say. So we're not trying to replace monitoring systems. We're trying to integrate with them. The philosophy here is that you already have something running somewhere, and you're probably already collecting monitoring metrics. So we would like to integrate with it and just surface those metrics to inside Mist, so you can have your sources of data right next to your action taking, let's say, mechanism. So I see this data, what can I do now? Do I need to stop a VM? Do I need to create a new one? Do I need to scale it up? Do I need to scale it down? At this point, we're integrating with InfluxDB, and that's why we allow our end users to bring their own. And maybe, I don't know, maybe in the future we're expand. But the interesting point here is that we have looked into Prometheus as well before doing the integration with InfluxDB. And although it has some good points, it didn't really work for us. Maybe this is specific to Mist, but you have to keep it in mind that Prometheus follows a pool model. So it would be hard for us to justify opening holes in your firewalls just to get your data out of there. With Telegraf and InfluxDB, we're going with a push model. With Prometheus, you can tweak it to work under a push model as well, but then you hit some issues with the reading performance. So although writes are pretty good, reading is kind of slow. Yeah, so that's why we went with InfluxDB.
Okay, all right, great. Let's see, we have another question, a follow-up question from Jayesh. He also asks, how is Mist storing secrets such as AWS IAM access key ID and key secret? Is it stored encrypted?
We are storing them currently in Vault, HashiCorp's Vault. And for our next version, we will roll out Vault support to our end users as well. So here the idea would be that, similar to InfluxDB, you will be able to bring your own HashiCorp Vault connected to Mist, and you will be able to do two things there. Mist will be storing your credentials there, but it will also be able to show you like a secret section, similar to the sections you've seen before, where you can store pretty much any secret you might have, like passwords and things like that, and then share them with your team through there. We don't have immediate plans to add more secret engines, but we are actively looking into it. So first, it will be HashiCorp Vault, and we'll see from there.
Okay. All right. Great. Next question is from Daniel. He asks, is there an event correlation engine to automatically create actions possible in the future?
Yeah, we have something like that in beta, but we will probably rewrite it in the near future. So there is a mechanism which applies some, let's say, common sense thresholds and filters to the values that you're getting from your monitoring metrics or your cost analytics and things like that, and proposes action-taking steps like, oh, we detected that this VM of yours is sitting idle, click here to scale it down. Or, hey, we detected that this VM is having a hard time, click here to scale it up. But we are revising it as we speak, and it will probably be a total rewrite. So it's like more of a proof of concept. But yeah, this is something really interesting. This is something that we would like to do in the medium term.
Awesome. All right, great. Once again, if you have a question for Chris, go ahead and use the question and answer tab on the interface or the chat tab, and we will go ahead and get to it. The next question here for you, how quickly was your team able to go from pre-production to production with the InfluxDB?
Oh, that's a big question. So first of all, we didn't start with InfluxDB right away. So we had a period where we were trying different things out, and we were trying to understand what is more suitable for our needs. I'd say that this period was pretty much a month. But from there on, things moved really quickly. So we were able to go to production in less than 2 months, if I recall correctly. And that's with, the full integration that I showed, end-to-end integration with Telegraf and InfluxDB. The installation process of InfluxDB is fairly simple. So if you're not looking to do some really deep integration or anything like that, you can be up and running in no time practically. So if you're sticking to, let's say, the more mainstream application of InfluxDB, which is, install a database, install your agents, and connect everything, it just works. So it's really easy to get going. But if you're looking for deeper integration, it depends on the use case. So it's really, really hard to say. In our case, it took about 3 months from day one and beginning of research to deploying to production.
All right. All right, great. Next question here. Which solutions did you evaluate when looking for a time series database?
Yeah, okay. So I already mentioned the case of Prometheus.
Yes, yeah.
Yeah, so we already looked into timescale DB, but we moved away from that, mostly because of its license. It's licensed under a code available license, which was a pretty much deal breaker for us. We were looking for something that was really, really open source, so we don't have to deal with all the complexities of weird licensing. And because we are running Mist.io as a service, we're shipping it on customer premises. We also have the open source version, so it can get really complicated. So we wanted to avoid all that. And we also looked into solutions that are, let's say, not time series specific, but can be extended to serve time series scenarios, like Foundation DB, for example. The problem there is that, although we saw that they're performing well, the glue required to make a monitoring system out of them is quite important, and it would slow us down considerably. So yeah, I'd say like in total 3 buckets: code available things. We didn't go with them because of the licensing. Then more general purpose in memory data stores like Foundation DB. We didn't go with that mostly because of the more integration effort that was involved. And then I would put Prometheus in a category by itself probably, but maybe there are a couple of other pool models out there which didn't really work for us for 2 reasons: the pool model and the read performance.
All right, great. All right, so we have a couple more questions that have come in, but there's plenty of time. If you do have a question, go ahead and send it on in, and we'll just keep rolling as long as we've got the questions here. Next question here, Linda just sent this one in. Let's see, is your runtime series on 2 VMs containers? How is the accuracy of time for data to stream in?
I'm not sure I get the question, to be honest.
Okay. Okay, Linda.
If you can please clarify a little bit. I'm not sure I understand the question.
Yeah, if you want to go ahead and send a follow-up to clarify. Meanwhile, we'll move on to a couple of other questions that we have, and then hopefully we can come back to Linda's. Let's see. Here's one for you. Why is timestamped important to monitoring multi-cloud environments?
I would argue that is important in managing any environment. Specifically for multi-cloud, there is an additional layer of complexity because you have all those systems running on many different places. So you need to correlate stuff, and all those devices, servers, call it as you like, they're creating a huge amount of data. So the best way to do that is through like a time series. So you can quickly correlate from many different sources in pretty much any cloud out there, and you can also detect, what caused the problem and where exactly the problem happened. So, yeah.
All right, great. Okay, let's see. Here's another one, really good one for you. Where to go? Here we go. So why should I use Telegraf instead of writing directly to InfluxDB?
Yeah, well, you can do that as well. I wouldn't recommend it, to be honest, but you can do it if you like. Now, I don't really see a good reason for writing directly to InfluxDB, to be honest. Telegraf gets all the points right, and plus it brings some features that you don't want to call by yourself. For example, what happens when the network goes down? Telegraf can store your metrics locally and then send them to your InfluxDB when the network connection is restored. Then you can also leverage a big number of plugins for monitoring applications, for example. Why should you write that from scratch again? It's there, it's working nicely. And if you're worried too much about the overhead, it's rather lightweight. So it won't cause a lot of slowdown to your server. It's working without you even noticing it, actually. So it's open source, it's lightweight, it has a lot of functionality built in. I don't think it would make sense to do anything else. You would end up writing your own agent, which probably would be worse than Telegraf. So I don't see a real reason for doing it. Maybe in some very, very specific use cases, but overall, I can't think of any good reason for not going that way.
Okay. All right, great. We did get clarification from Linda in the public chat there. She said a same data to 2 time series databases running on 2 containers. So what is the timestamp difference between the 2 time series database?
I don't know. It's the it's the answer. I don't know. It's interesting here though to note that Telegraf is mitigating some of the synchronization issues by itself. So as long as the original timestamps are correct on the Telegraf layer, then it might take a while to get to your InfluxDB, but once they're there, the timing will be correct. So you can rely on Telegraf to keep your clocks in sync and apply the right timestamps to your data points. You might see a little bit of a lag depending on your networking and all that, but eventually there will be there and they will be in sync.
Okay. All right, great. So we are about 10 minutes to the top of the hour. So we do have a few minutes left, 9 minutes. We do have a few minutes left for the question and answer period. We have one more question here. So I do invite anybody who does have any last minute questions to go ahead and use that question and answer tab and get it on in. How often should I collect metrics from my infrastructure?
Again, this depends on your situation. For mission critical applications and servers, this should be really high. The frequency should be really high. The less critical the workload and the server, you can adjust the frequency accordingly. So we can see we see anything from up to 1 second frequency all the way like to several minutes. And you have to tune this according to your needs, because storing is costing you money, both in compute time as well as disk space. So working at top frequency is not usually a good idea. You have to tune it the way that works best for your case, so you get like both the benefits of good monitoring as well as some optimization of your resources. And by default, in our case, we zip Telegraf with a frequency of 10 seconds, which is rather good for a big number of applications. But the nice thing about it is that you can just change it at any time, and you can change it on the Telegraf layer, and you don't have to do anything in the InfluxDB layer. It can ingest any frequency coming from any source, and that's really, really nice. This is something that we didn't have with Graphite. So you had to be really, really specific about what's your ingestion granularity. And yeah, with Influx, you don't have to worry about that. You just configure it on the Telegraf layer, and then it will be automatically stored in InfluxDB, and that's it.
Awesome. Awesome. All right. Well, we have about 7 minutes to the end of the hour. That's all the questions that we have in right now, but I'm going to go ahead and leave the question and answer tab open in case we get any final last second questions come through. While we're waiting, I just want to remind the audience that today's event has been recorded. So if you missed any or all of the event, or if you just want to watch it again, you will have the opportunity to do so. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the DevOps.com website, so you can always go look for it there. Just go to DevOps.com/webinars, look in the on-demand section, and it should be right there waiting for you. Also, another quick reminder that we have those great handouts in the handout section, so please avail yourselves of them. Go ahead and download whichever one or both that you'd like, and there's some great information in there, so highly recommend that you check out those handouts. All right, we haven't gotten any more questions in, so I'm going to go ahead and do the drawing for the 4 $25 Amazon gift cards. Okay, our first winner today is Daniel B. Congratulations, Daniel. Our second winner is Michael B. Congratulations, Michael. Our third winner today is Martin C. Congratulations, Martin. And our final winner today is Scott D. Congratulations, Scott. We'll be following up with all 4 of you via email to get your Amazon gift card over to you. So please check your inbox. And if you don't see anything there, please check your spam folder. Chris, thank you so much for a great presentation today. Like I said before, I'm a big fan of the demos, so I particularly enjoyed watching those. But I do appreciate your time and your expertise. Thanks for joining us.
Thank you. Thank you all.
All right. I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody, and please stay safe.